This is a tutorial over section 12.4. 12.4 is mostly with inscribed angles. This can be a very tough section. Inscribed angles can get very messy inside of a circle because they can put 4 or 5 of them in there. The biggest thing that you need to remember for inscribed angles is that the angle is always equal to half of the arc. So what you see in my diagram here is you have arc AE. Notice how each one of those highlighted angles are intersecting angle or arc AE. Since they are all intersecting arc AE, that means all 3 of those angles have to be congruent. And using our inscribed angle rule, if we know the arc, we just take half of it in order to figure out what the measurement of the angle is. The measurement of the angle then is going to be 50 degrees. And since all of them are intercepting the same arc of 100 degrees, then all of those angles have to be 50. I don't know if Miss McGrew told you, but when you are doing inscribed angles, it gets very helpful if you start highlighting angles in a circle, because when you start highlighting angles, then you can tell what arcs they're going with, and you can also tell if there's any congruent angles in there or congruent arcs in there. So please use the highlighters. Do not shy away from those. Those may help you when you solve these types of problems. So I have a few examples that I want to show you. This first example is we want to figure out what that question mark is. Now notice that this TW is going through the center of the circle, so that means it's the diameter, leaving arc WXT as 180 degrees, which is a semicircle. If we already know 116 degrees, that XT, then we can find XW. XW then is 64 degrees. That's 180 minus 116. Since we know this arc, looking at our diagram, we have this inscribed angle right there, this XYW. Since we know that's an inscribed angle and we know the arc, we're going to take half of the arc, and that's going to give us our angle. So half of 64 is going to be 32. So our angle here equals 32 degrees. Now this next one, again, like I said, it's getting kind of messy with all of these angles in here. So sometimes it's helpful even to just start highlighting angles if you needed to. What we have here is this inscribed angle. We know the measurement of 48 degrees. If we know the angle, then we can find the arc by doubling it. So if we need to double that angle, we are going to get 96. So KL, arc KL, is going to be 96 degrees. Notice that JL is a diameter, leaving JKL, arc JKL, as a semicircle, which leads up to 180 degrees. When we take 180 and we subtract 96 from it, we are going to be left with 84 degrees. So this angle, or this arc, is going to be 84 degrees. So JK is 84. These next one that I have here, notice that we have this inscribed angle right here. We have that measurement to be 44 degrees, so using our inscribed angle rule, the angle equals 1/2 the arc. So if we know the angle, we can also double the angle to get the arc. So 44 doubled is going to give me 88. Notice how FD is a diameter. Since this is a diameter, then FED, arc FED, has to be a semicircle, which has to add up to 180. So if we already know this 88 degrees, we're going to subtract that from 180 to get 92. Now, notice that this is also an inscribed angle right here, and that arc is 92. So remember, the arc is equal to the angle, so the angle 2x plus 22 equals 1/2 the arc. Well, half of 92 is going to equal your 2x plus 22. Let's see what would that be. 46. Okay, so since that is 46, we can go ahead and solve this. 2x is equal to 24, so x would equal 12. This next one, when you have an inscribed quadrilateral, what that means is all of the vertices of your quadrilateral, your four-sided figure, is inside of the circle. So they are creating a quadrilateral inside of the circle with all of the vertices on the circle. When we have an inscribed quadrilateral, all of the opposite angles are going to be supplementary. So W and R are supplementary, and Q and S are supplementary. What we have here is a system of equations. So here are my two angles added together, set it equal to 180, because that's what supplementary means. Here's my other two angles added together and set it equal to 180. This next step, all I did was I combined our like terms to get those two equations. In order to solve a system of equations, you want to either use elimination or substitution. I prefer elimination, but if you feel like you want to do substitution, please feel free to. I'm going to subtract my 22 to get the 158 in this equation right here. Notice that we have 7y in both of those equations. So if we multiply the bottom row by a -2 or a -1, we are going to add them together and get -2x equals -22. So x comes out to be a positive 11. In order to find your y, go ahead and plug your x back into one of those equations and solve for y. Y comes out to be 10. So the main thing you need to remember about 12.4 inscribed angles, just get a highlighter out, get a marker, get a pen, do something. That's going to help you solve those inscribed angles. Inscribed quadrilaterals, always opposite angles always add up to 180 degrees. And the inscribed angle rule, do not forget that. Angle equals 1/2 the arc.